Hello, it's me again. I am going to go over number 7, and this one is talking about a ball that is thrown upward from a height of 15 feet with an initial upward velocity of 5 feet per second. Use this formula again to find how long it will take for the ball to hit the ground. So again, they're asking for time, but I've got to plug into this vertical motion formula. So my equation is actually h of t equals negative 16t squared plus v, which is 5, so 5t, plus s, which is your starting height, which is 15. Now, if you think about it, it opens down, it's a parabola, it opens down, c is 15. So we've got this thing happening where the starting height's 15 and it goes like this. And the question is asking, how long will it take for the ball to actually hit the ground? So this is where it hits the ground again. So it wants how long it will take. This is the t-axis, this is the h-axis. So it wants this t value, this time value, where it will actually hit the ground. So we want our time value when it hits the ground. Well, when something hits the ground, what's its height? Its height is 0. So this is the t-intercept. And remember, if you have a t-intercept, that's where h is 0. So what I'm going to do is I am going to plug a 0 in place of this. So I get 0 equals negative 16t squared plus 5t plus 15. Now to use your calculator, I'm going to say it again. There are several ways to do this. My preferred way is this. In y1, you will put the vertical motion formula, except we won't put a t, we'll put an x. So I put an x, so x squared plus 5x plus 15. And then in y2, because I want the height, the y, to be 0, I'm going to put a 0. And what that's going to do is it's going to graph this parabola and this line right here. And the only way you're going to see it graphing this line right here, this t-axis, is if you have one of those fancy calculators that has color. Okay, so you can see that it's actually drawing that line. Now once you do that, let me grab a calculator. Hold on. So I'm going to y equals, and I'm going to type this in. So I go to y1, I clear out whatever's in there, and I type negative 16x squared plus 5x plus 15 into y1, and in y2, I put a 0. Okay? Now, I'm going to hit zoom 6 because that'll just get me in a standard viewing window. Get us all on the same page. So zoom 6 is zoom standard, going from negative 10 to 10 and negative 10 to 10. And here's what I see. Remember what I desire. This is not asking me for the maximum height. This is not asking me for the time that it took for the ball to reach the maximum height. This is asking for the time it took for the ball to hit the ground. So on this viewing window, the zoom standard, do I see where it hits the t-axis over here? Yes, in the first quadrant, I sure do. So since I see what I need, I don't need to worry about zooming. I don't need to worry about adjusting my window. I just need to go to second calc. So second calc, and I am setting this up to find an intersection point between this parabola and this line that we had it draw for us, y equals 0. So I want to go to intersection. Okay, so that's number 5, so I'm going to hit 5. Now it's going to say first curve. Well, I don't see Blinky Man right now at all. I want to move Blinky Man where Blinky Man's around this intersection point that I want. So I'm going to hit the down arrow. That gets Blinky Man down to the x-axis or the t-axis in context. And so when I hit the down arrow, that's what it looked like. Now I'm going to move it over right on top of what I'm trying to find. So I moved Blinky right on top of what I'm trying to find, okay? Then I hit enter. Once you move Blinky Man where you desire, you hit enter 3 times. Enter, enter, enter. So enter, 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 and I get that intersection point right there is 1.14, 0. I got 1.14, 0. So this point right here, we just use our calculator to get that it's 1.14, 0. So are we able to answer the question? Do we have the t value or the x value? Well, yes, we do. And the height is 0 because we made that work. We made that happen. So how long will it take for the ball to hit the ground? It will take 1.14 seconds. It will take 1.14 seconds for the ball to hit the ground. Period. It's always good to try your best to use complete sentences and correct capitalization and punctual, what's that called? A period. That's always a real good thing. Thank you guys. Bye.